Today's lecture is on linear functions, and we want to start with this nice simple question. What is a linear function? And so to understand what linear functions are, you should probably try to understand where you actually use them, and you do use them every day. A linear function really occurs when you have this idea of a constant rate of change, which when we think of rate of change with respect to linear functions, we'll call it slope. And so when do we have a constant rate of change? Well, if you go to a gas station and you think about this, there is a constant rate of change, at least for that day there, and it's in the form of dollars per, at a gas station, it'd be dollars per gallon. So you use a linear idea when you purchase gas. So if you have basically, let's say, gas costs $3 per gallon and you get 10 gallons, you know it's going to be $30. We also use this concept when we go to the supermarket, and if you buy a hamburger meat, it's usually dollars per pound, or chicken, dollars per pound. Usually that week or that month, the cost is pretty constant. And so if you buy hamburger meat and you buy 5 pounds, you're going to take 5 times whatever it is, dollars per pound. And this generalizes to almost everything we do when we purchase something, dollars per bag, dollars per bottle, dollars per item, dollars per ticket. So you're using the concept of a linear function all the time. In fact, just a year ago, I went to Mexico, and I knew that it was 13 pesos per dollar. So if I wanted to exchange $5, I knew I'd take that times, let's say, 5, so 13 times 5, which is 65 pesos for my dollar. And so that's what a linear function is. You have this constant rate of change. Let's take a look at an example of this, because I know everybody in here has seen linear functions before. And so we want to use the tables below to answer the questions. And so I give you 2 tables, table A and table B, and we want to determine which table is linear. So take a moment and look at the 2 tables, and hopefully you can see they are slightly different. So in table A, notice the pattern versus table B. So in table A, when the inputs change by 1, the outputs are changing by what? So look, you go from 1 to 3 to 5 to 7. So hopefully you say, oh, I'm adding what each time? I'm adding 2, which is a very simple idea. You add the same number each time as you go to the next step. Whereas over here in table B, instead of adding, you're actually, well, you go 2, 4, 8, 16. So you're actually multiplying by 2 each time. So these are 2 different phenomenon, and one we're adding 2, and the other we're multiplying by 2. Which one do you think is linear? And it's probably the simpler of the 2, and hopefully you say table A. And table A is a linear idea, and so which table is linear? I'd say table A. Whereas table B, we're going to learn this is an exponential idea. So to model the data in table B, we'll use what's called an exponential function. So when you have a linear function, basically you add the same number each time, whereas when we do exponential functions, you'll see that we're multiplying by the same number each time. And so it sort of gives you an idea of why linear functions are so important. If you have some sort of situation where you're adding the same number each time, like you're pumping gas, so it's the same dollars per gallon, so each gallon you pay so much. Or if you go to the theater and you get a movie ticket, it's dollars per ticket. So if you buy 1 ticket, it may be $7, 2 tickets, maybe 14. So if you're adding the same number each time, to model that phenomenon, you're going to have to use a linear function. Whereas if you're multiplying by the same number each time, like we're doing over here, we're going to learn you have to use an exponential function. All right, so let's move to part B. What is the slope? And so the slope is the idea is how much are you adding each time? So we're going to talk about this in a minute, but the slope, we usually use the letter M. And a lot of times we're told it's the rise over the run, or really just the change in the output over the change in the input. And we can even be a little bit more fancy. If you give me x and y, I know the output is y, so I've got to write the change in y or the change in x. Right, so these are all formulas we can use, but you know the answer. If you increase your input by 1, your output increases by 2. So this answer should be equal to 2. Since you're increasing by 2 each time, and you're increasing by 1 on the left, my slope is 2. Find a formula for this line. So without knowing anything about linear functions, you should be able to kind of think about this and say, well, how can I write down a formula? I want to write down y equals what? Well, I know if I plug in 0, I get out 3. And if I plug in 1, I should get out 5, which is 2 more. If I plug in 2, I get out 2 more after that. So how can you write this down? The idea is if you start, I start at 3, and then I'm adding 2 each time. So how do you write down add 2 each time plus 2x? I'm adding 2 each time. So now think about this. Now normally we'll probably write this as y equals 2x plus 3 because we've all been taught this formula, y equals mx plus b, where m is the slope. So remember this formula that you've seen before, m is called the slope, and b we often call the y-intercept. Or I think a better point of view is actually, this is your initial value. I mean, if you think about this, this is you use linear functions all the time. And just as an example, just about a year ago, I wanted to figure out how much I had put into an investment. And I originally put in about $2,000. And each month, I put in $50. So if I want to figure out how much I got out, I initially put in $1,000. And each month, I put in $50. So 50, and I'll use t for time. And so this is how much I put, use amount, A, into my investment. And if I want to figure out after, let's say, 1 year how much I put in there, what I would do is I'd figure out A of 12. So functional notation. And I'd say, okay, this is 50 times 12 plus 1,000, and I can use a calculator to figure this out, or you can do it in your head. This is going to be 600 plus 1,000, so I put in $1,600, and then I can look at how much is actually in there to figure out how much should I actually make to decide whether I want to close out that count right now, or I need to wait a couple more months until the market maybe comes back up because I need to have access to that money for some sort of expense. And so that's how I've actually used linear functions in just the last year or so. But you do use them all the time, like I said, when you purchase gas or buy meat or buy any sort of item. If it's dollars per item, even when you drive, we call this miles per hour. It tells you how fast you're going per hour. And so that kind of helps you calculate how long it's going to take you to go a certain distance. If you're going 60 miles per hour and you go for 2 hours, you're going to travel 120 miles because you're going 60 miles per hour. So that's all kinds of applications of linear functions. Let's talk a little bit more about slope, because this is really important that everybody understands intuitively what slope is in the graphs of lines. So basically, you have two graphs of lines. All right, the graph of a line, it can either go up or it can go down. And so these are my two lines. And now when it goes up, what do you think? Is my slope positive or negative? And hopefully you say, oh, it's positive. And so if you're going up, I have positive slope, whereas if you're going down, you have negative slope. And I always like to use the following picture here to give you guys a good feeling for what slope is. So here you have, let's say, no slope. Here you have a little bit of slope. And here you have, let's say, a lot of slope. Let's not make, I don't want it to be vertical. So that's too much slope, let's say. I want a little bit less, but I want you to see it's going up really sharply. So a little bit more. Then you're going down a little bit, and then you're going down a lot. And so I'd say no slope would be m equal to, what do you think? No slope, hopefully you say m equals 0. If it's going up a little bit, this might be m equals 1. If it's going up a lot, this slope might be really large, like let's say 100. Whereas over here, instead of being positive, this would be negative, so m equals negative 1. And this, going down a lot, would be like maybe negative 100. So intuitively, what this m equal 1 means, it means if you go over 1, you go up 1. Here, if you go over 1, you actually go up 100. Whereas over here, if you go over 1, instead of going up 1, you go down 1 because it's negative. Over here, if you go over 1, you go down 100 to the next point because it's negative. And here, if you go over 1, you go up 0. So that's a horizontal line. There's also vertical lines. For a vertical line, some people define this slope to be positive infinity or negative infinity or just undefined. Because if you go over 1, where do you go? Right, so we could say the slope is undefined. But what's really important here is that if you have a line that's going up, its slope is positive. If you have a line that's going down, its slope is negative. So let's look at an example trying to understand slope better. So we're going to use a graph to answer the following questions. So first we're going to find the slope. And in the beginning, we can always use formulas for this. Right? The slope is just this idea of rate of change. So the average rate of change if you want. So it's a change in the out or the change in the in, or it can be a bit fancy, say the change in y or the change in x. And from this picture, I like just to look for the change in y's and change of x's, and I really just look for a triangle. So if you look in this picture, there's a nice point here and a nice point there. Right, this point is called the x-intercept, where y-intercept, I'm sorry, this is called the y-intercept, whereas this point is called the x-intercept. And so if you see this, there's a nice triangle right here where this has, height 3 and this has length 5. And so I know it's going to be the change in y is 3 over 5. And because it's going down instead of positive, you can put a negative sign. And so what does this mean? It means if you go over 5, you go down 3. Or you could say if I go down 3, I go over 5. That's what this slope means. Or you could actually say if I go over 1, just 1 unit, I go down 3/5. Go over 1, down 3/5, over 1, down 3/5, over 1, down 3/5, over 1, down 3/5, and you go down a total of 3 units. So think about that. So I think it's important for you to understand. So if I'm going to write the formula of this line, I can say y equals, and I can say, well, I start at height 3, and each time I go over 1, the slope says I go down 3/5. So I'm going to go over 1, I go down 3/5 each time. So it equals 3 minus 3/5 x. And we can write this as y equals negative 3/5 x plus 3. And so hopefully this makes sense to you, what this is saying. So this formula says, hey, you start at 3, and each time you go over 1, you go down 3/5. And it's going to model that line. It's really important that you can attach stories to formulas if you can, especially very simple ones like this. Like this formula right here, I could say something like, okay, well, I have $3 in my piggy bank, and if you know this, negative 3/5 is actually negative 0.60. And so what I can say is I have $3 in my piggy bank, and let's say each day my sister steals 60 cents from me. How much do I have after X days? And so this formula right here would model that. So after 1 day, she stole 60 cents. So I have $2.40 if you plug in 1. After 2 days, she stole a total of, what, $1.20? Because 2 times 0.6 is $1.20. And so then I'd be left over with, what, $1.80 in my piggy bank, and so on and so forth. So you can come up with little stories to sort of fit the formulas you find, which I think is really important. It tells you that you not only tell it from you understand from an algebraic point of view, but you understand from intuitively what it represents. All right, so let's talk then about the two formulas. I've already introduced this one formula, y equals mx plus b, but it's an important formula, and so let me talk about it some more. Here, remember, m represents the slope of the line, whereas b is our y-intercept, or you could say it's your initial value. One reason why this formula is important is because if you want to know the slope of a line, I give you the formula, you simply need to look at the coefficient in front of x to tell me what the slope is. Or if you want to know the initial value, you just look at this number here, which is represented by a letter b. So let's do an example of this so you can see why this formula might be important. And we call it the slope-intercept form because it's given by the slope and intercept, y equals mx plus b. And on this one, we want to use the equation to answer the following questions. So find the slope of the line, and then we want to graph it. So the idea is take this equation and solve it for y. And so to solve this for y, we have 4x plus 2y equals 6. And so we'll move over the 4x. We'll subtract 4x from both sides. And we'll get 2y equals 6 minus 4x. And then we'll divide both sides by 2, so y is equal to, and so we'll divide everything by 2. So this whole thing gets divided by 2. And here's where students make a mistake. Instead of giving 2 to both of these things, sometimes students just give the 2 to one of these things. Remember, when you divide and you're adding or subtracting on top, the 2 gets given to both of these things. So it's 2 divided by 6, which is 3, minus 4x divided by 2, which is a 2x. So my answer is y equals 3 minus 2x, or I could rewrite this as y equals a negative 2x plus 3. So it's in y equals mx plus b form. Then it's really easy to figure out the slope. So m is equal to negative 2 in this case. And if I want to graph this thing, so let's graph it. So if I want to graph this, here's my x, and here's my y. And I'll use black for my point. I know my initial value is 3, so when I plug in 0, I get out 1, 2, 3. So I have 1 point right here. And because it's negative, it says if you go over 1, so if you go over 1, you go down 2. So 1, 2. So this is a point right here, 1, comma 1 on my line. And you simply connect the dots for a line. So it should look just like that. So it goes to the point, if you want 0, comma 3, that's the y-intercept. And it also goes to the point 1, 1. Because the idea of the slope, if the slope is negative 2, means you go over 1, you go down 2. Let's talk about the next formula. So the next formula is the slope point form. And the idea of this is you're given slope and point. This one is the more useful formula really in this class. And so in high school, basically, I learned this. And in this class, I want to focus on this formula. And the idea behind this formula, if you think about this, you need slope and point. So what they give you, or what you'll be given a lot of times, is you'll have the slope and you'll have the point on the line. So this is the point, x sub 1, y sub 1. And to find the formula of this line, all you need is the slope and some other point. So if give me any other point on this line, so this point can vary. And we know that the slope is constant. So where does this formula come from? This formula comes from the idea that we know the slope is the change in the y or the change in the x. So it's really y minus y1 divided by x minus x1. This is always constant. So if you pick some point on a line and you let some other point vary, we know that this relationship always holds. And if you multiply both sides by this denominator, you're going to get y minus, y minus y1 equals, and so you multiply both sides by x minus x sub 1. On the right-hand side, these are going to cancel. On the left-hand side, you're going to get this m times x minus x sub 1. And so that's why this relationship holds. And now let's use it in an example. And we have two examples here, part A and part B. And we're going to start with part A here. So you give me 2 points, negative 2, 8, and 2, comma 6. And I want to use this slope point form to find the equation of the line to these 2 points. The first thing I really like to do is I like to draw a picture because it's easy to make mistakes. And so I can draw these 2 points. Let's do it in red. I can go over 2 and up 8. You don't have to draw the hash marks. Just make sure it's in the right quadrant. Remember, there's 4 quadrants, 1, 2, 3, 4. And so this is in the second quadrant, whereas this point here is in the first quadrant, so 2, 6. So let's just put it right here, 2, comma 6. And you can connect the points and see the line. And what's important, I guess it should go through the points. Let's make sure that point's there and that point's there. As you can see that the line's actually going down, so the slope should be negative. And that'll help you from making actual mistakes. And so what I want to use is this point slope form. So I have y minus y1 equals m times x minus x sub 1. And you have lots of choices for points. It does not really matter which one you choose. I'll probably choose 2, comma 6 as my point because I like to stay away from negatives. And I need to find my slope. And so remember, my slope is my rise over the run, so my change in y for the change in x. That's easy to find. I can take 6 minus 8. That's my change in y, so 6 minus 8. And if you start with this coordinate on top, you better start with this coordinate on bottom, or you're going to get the signs flipped. So then that's 2 minus a negative 2. And you'll see on top I have negative 2. And on bottom I have 2 minus a negative 2, which is a positive 4, because a minus a negative is a plus. And so this is equal to negative 1/2. And then good, it's negative, so that's what I would expect because the line's going down. And so then I can plug in y minus, and I'll choose this for my point, so y sub 1 will be the number 6, equals negative 1/2 is my slope, so I plug that in for m. And then x minus my x sub 1 will be that number 2. And then I simply solve this equation for y. So I have y minus 6 equals, multiplied through by the negative 1/2, so negative 1/2 x. And then I have negative 1/2 times a negative 2, so that's going to be plus 1, because the 2's will cancel, and a negative times a negative is a positive. And then I'll add 6 to both sides, and I get my answer, y equals negative 1/2 x plus 7. And I can check my answer by plugging in this other point here. And so if you plug in negative 2, you better get out 8. So when you plug in negative 2 for x, I get negative 1/2 times negative 2, which is a positive 1, plus 7, which is 8. So this checks. That way I know that this is actually the formula for the line. I didn't make some silly algebra mistake. Now the second part, part B, says find the linear function where f of negative 2 is equal to 8 and f of 2 is equal to 6. So hopefully you realize that this is exactly the same question as above, just written in different notation. It's written in functional notation. So the input is negative 2, the output is 8. The input here is 2, where the output is 6. So input 2, output 6. So if I was going to do this problem, I probably would do it exactly the same. The only difference is in the end, instead of writing y equals, I'd write f of x equals, because they gave it to me in functional notation. So I'll write negative 1/2 x plus 7. Exactly the same problem, just written in a different notation, written in the function concept. This is more of a geometric way to write it. And this is how to write it functionally, how we think about it maybe more today than we used to think about it in geometric terms. So the function concept's more popular. So let's do one final little review here to kind of cover what we talked about. What is a linear function? Basically, if you add the same number to something each time, you're going to model it with a linear function. So you have this constant rate of change. And when we're talking about linear functions, we call this the slope of the line. When the slope is positive, the line goes up. When the slope is negative, the line goes down. When the slope is 0, it's horizontal. And then if it's vertical, perfectly straight, the slope is undefined. When we have the graph, like we said, there's basically two graphs. Either goes up or goes down. And understanding slope, I just kind of mentioned that. And there are two formulas. There's a slope-intercept form because they give you the slope and the intercept. And there's a slope point form because you need to find the slope and a point to do it, to find the formula. And that's basically it.